Okay, let's look at this next exercise. Suppose f of 0 equals 3 and f prime, so that's important, f prime is the function shown below. They're also telling us that g of x, some new function, is x squared plus 1 times f of x. So this to me right here is screaming product. So when they ask us to go find g prime of 0, I first think about g prime of x by product rule is going to be the first factor times the derivative of the second plus the derivative of the first times the second. And so g prime of 0, so this problem is really just a review from the last unit. So 2 times 0 times f of 0. Okay, 2 times 0, that's 0, times f of 0 is 1. So all of that's just 0. Here I have 1 times f prime of 0. So I go to the f prime function and see, sorry, this was not 0 times 1. This was 0 times 3 because f of 0 was 3. So this is 0 times 3 is 0. But here, f prime at 0 is 1. So now I'm getting 1 times 1. 1 times 1. So g prime of 0 is 1. Right? 1 times 1 plus 0. Okay, so is g increasing at x equals 1? So that's asking a question about whether g prime is positive or negative at 1. So they want us to now find g prime of 1. So I already know g prime of x. I already know g prime of 0. Now let's find g prime of 1. So this is going to be 1 squared plus 1 times f prime of 1 plus 2 times 1 times f of 1. Now, 1 squared plus 1, that's certainly 2. F prime of 1, we have to go to this graph and sort of estimate what that slope is. So it's maybe 1 or 2 or 1.5 or something in that area. So something that's approximately some positive value like that. And then f of 1, do I know what f of 1 is? Well, I don't know its exact value, but I do know that f of 0 is 3. And at 0, the function is increasing, right? So f prime must be something bigger than 3. So this is going to be something, I don't know, maybe not approximately, but just like greater than 3, we'll just say. And ultimately, all that really needs to know is, I need to know, is this result positive or negative, right? So it actually doesn't matter the value of it. It's a positive number times 2 plus another positive number times 2. So this is definitely going to be positive. And so therefore, g is increasing. Okay, this next part is asking us for g double prime. So now I need to take the derivative. So remember that g prime, I know you have it written there. Mine would have to scroll up. So I'm just going to write it here. Here's g. So what is g double prime? Well, I'm going to need to use product rule again, right? So I've got the first times the derivative of the second, would be the second derivative, plus the derivative of the first times the second. All of that is product rule on this part. Now I need product rule on this second part. So we've got the first times the derivative of the second, plus, bummer, I'm going to run out of room. Then I've got the derivative of the first times, oh, I said that wrong, hold on. Oh no, that's right. Okay, so derivative of the first times the second. Okay, so to clean this up, we've got x squared plus 1 times f double prime plus, like terms here, I've got 4x f prime of x plus 2 f of x. So we're asked to find g double prime of 0. So it's going to be 0 squared plus 1 times f double prime of 0 plus 4 times 0 f prime of 0 plus 2 f of 0. F of 0 we know is 3. That was given in the original problem up above. So I've got 2 times 3 here. This 4 times 0 times the derivative of 0, that's all going to be 0 because I've got a 0 in there. And then here I've got 1 times the second derivative at 0. So I go back to look at f prime, and I know that f double prime at 0 is going to be the slope of this function here. So the slope here is going to again be something positive. So I think I can just go get away with something that says positive. So positive value plus some other positive value. So this result is positive overall. So is G concave up at x equals 1? Well, we'd have to repeat the same problem, the same result, second derivative at 1, and that would be something like 2 times something approximately like, so now I'm looking at the slope of the original function f prime, so that would maybe be something positive like 1/3. Then this would be 4 times 1 times f prime of 1. F prime of 1 is a little bit over 1.5, plus 2 times f of 1, and f of 1 we already estimated to be a little bit greater than 3. So again, we're looking at all positive values. So the result is positive, and that's telling me that this graph is, in fact, yes, concave up at x equals 1.